Hi, I'm 190523boels, researcher at the Freudenthal Institute of Utrecht University and mathematics teacher at a secondary school. I conduct this research together with Arthur Bakker, Wim van Doorn and Paul Drijvers. Our research is about developing statistical literacy through histograms, and in this video abstract I unravel what makes histograms so difficult to understand for people. In my other video I explained how lookalike graphs can tell a totally different story about a distribution, one of the key concepts or big ideas in statistics. In this video I wonder why people have difficulties with the big idea of data. So let's have a closer look at these two graphs here that look quite different. In the left-hand graph we have a case value plot with the birth weight of baby girls born in a hospital in Queensland, Australia in 1997. In the right-hand graph we have a histogram of the same birth weights of these babies. If we think about the big idea of data, two differences are important: the number of statistical variables and the measurement level. In this video abstract I focus on the number of variables. Most people will agree that this case value plot has two variables, name and weight. It's called a case value plot because every case has its own bar, thus weight. Note that the ordering of the bars can be done in whatever way you like, alphabetically by name, from lowest bar to highest, and so on. This is due to the measurement level of the names, which is nominal. Now I will transform this graph into a histogram through several steps. Meanwhile, we will discover that during these transitions, misinterpretations are induced due to the reduction of information. Information reduction is an important big idea in statistics. See the work of Gall and his colleagues. We now remove the names of the babies, here of course anonymized. This makes it no longer possible to know which baby has which weight. This misinterpretation that you can reorder the bars in a histogram from lowest to highest might stem from this information reduction step. Now we slit the dots to the left. This looks like a dot plot, but the axis is at an unusual place. Note that we have only one axis, thus only one statistical variable. Let's rotate the graph and mirror it. Now we get the messy dot plot that statistics educators like so much. You can now clearly see that we only use one variable, right? 3 more steps to go before we have our histogram, so hang on. When we bin the dots into intervals, we get a histodot. Here you can still see which dot is where. In our next step, the correct position of the dot is no longer visible, and that again causes troubles. The misinterpretation people have here with histograms, and probably also with stacked dot plots, is that only the middle value of a bar is observed. Note that we have removed the dots from the bars. We need a second axis to tell us how many dots there are in each bar. The misinterpretation people have here is that this means that there are two statistical variables depicted in a histogram, or stated otherwise, that a histogram depicts a bivariate distribution instead of a univariate distribution. What I do not show you is that we are not finished yet. If we want to use unequal intervals, we cannot use frequency anymore or count on the vertical axis. We need to use density instead. There is hardly any literature on that. So totally different graphs can tell you the same story. But some graphs, like histograms, can tell this story more clearly than others. So people have difficulties to understand the big idea of data. Some of the most common misinterpretations are that people think that the statistical variable is on the vertical axis instead of the horizontal. That people use the middle value of the bar in a histogram as the value of all cases in that bar, and that you can reorder the bars in a histogram, and so on. The gap in the literature is the role of the big idea data, and the role of information reduction, the latter also being called data reduction or aggregation. Thank you for watching this video.